Welcome to RT208 Engine Equipment and Maintenance, Module 2 Transformers. Objectives. At the completion of this presentation, the student should be able to do the following. 1. Define what a transformer is. 2. Identify the different types of transformers. And number 3, list and describe the different electric power losses. When we say transformers, the first thing that comes to our mind is the Autobots and the Decepticons. But here in our course, we will be talking about this kind of transformers. Okay? It is an electromagnetic device that converts voltage into higher or lower voltage. But first, let us see what are these electromagnetic devices. So these are the electric motor, the electric generator, and the transformer. Okay. So these electromagnetic devices are devices that converts electric energy into magnetic energy and vice versa, with the difference with the transformer. Electric motor is defined as a device on which electric current produces mechanical motion. So, pag sinabi electric motor, ito ay ginagamitan ng electricity in order to produce mechanical motion. Okay? So the type of motor used with the X-ray tubes is the induction motor. So induction motor is a type of motor used with X-ray tubes. It powers the rotating anode of the X-ray tube. So this is a picture and an illustration of the induction motor, in which there is two basic parts, the rotor and the stator. Okay? While electric generator, okay, functions, its function is to generate electricity from mechanical motion. So kabaliktaran siya ng electric motor. Very good. Okay, so they have almost the same parts, but they functions very differently, or their function is opposite. The electric motor uses electricity to produce mechanical motion, while the electric generator uses mechanical motion to produce electricity. Okay. And also, the electric generator has a commutator ring. It switches the direction of current through the loop. So you can see the commutator ring. Okay. Then transformer, it does not convert mechanical energy or chemical energy, but it changes the intensity of the alternating voltage and current. So it only works with AC or alternating current. Again, alternating current, okay, the flow of electron is alternating on opposite direction. And there are no moving parts in a transformer. It transfers energy from one circuit to another by means of electromagnetic induction. Okay, so there are no electrical connections between the two circuits. Okay, why does transformer not work in direct current? Because direct current does not or induces no current in the secondary coil, unlike the alternating current. Next is the transformer law. It states that the change in voltage is directly proportional to the ratio of the number of turns or windings in the secondary coil, or N sub S, to the number of turns in the primary coil, or N sub P. So the formula is V sub S over B sub P equals N sub S over N sub P. Okay, where V is voltage and N is the turns of the coil. You can see there the symbols. Okay, this is the transformer symbols. Voltage primary, secondary voltage. Okay, the windings or the turns. Okay. And now we discuss the two types of transformer according to voltage level. So first, the step-up transformer and the step-down transformer. Having known the transformer law, it is very important for us to know how to get the turns ratio. And in this question, we will be able to know how turns ratio is computed. So the question is the secondary side of a transformer has 300,000 turns and the primary side has 600 turns. What is the turns ratio? So the answer is, of course, first we must identify the given. Okay, so NS, or the number of turns in the secondary coil, is 300,000. NP, or the number of turns in the primary coil, is 600. And the formula is NS over NP. Then meaning it should be expressed as 300,000 divided by 600. And the answer is 500 is to 1. So the turns ratio for this question is 500 is to 1. Later we will know what's the significance of getting the turns ratio. Another question is getting the voltage. Okay, so there are 125 turns on the primary side of a transformer and 90,000 turns on the secondary side of the transformer. If the voltage is 110 volts, alternating current is applied in the primary winding. So what is the voltage induced in the secondary winding? So given the formula, Bs over Bp equals Ns over Np. So the missing is Bs. So we will be by cross multiplication, okay, Bp will be transferred to the other side of the equation. Thus, Bs equals Bp times Ns divided by Np. Okay. So substitution, okay, 110 volts times 90,000 divided by 125. 110 volts times 720, and the answer is 79,200 volts. Now in this, we will convert it into kilovoltage. So 79,200 divided by 1,000 is 79.2 kilovoltage. Now let us see the effect of the transformer law on current. So it is said that a change in current and a change in voltage is inversely related. Okay, so their relationship is inversely proportional. So the formula is IS over IP equals NS or NP over NS equals BP over VS. Okay, so that is the equation for the effect of transformer law on current. Okay, so let us try this question. So the turns ratio of a filament of a transformer is 0.125. Okay, what is the filament current if the current to the primary winding is 0.8 ampere? So again, let us identify what are the given values. So the given values is the turns ratio. So meaning we will be having the NS, NP and NS is the turns ratio. Okay? And then we have the primary current. So the missing one is the secondary current. So the formula will be IS equals IP times NP divided by NS. So substitution, 0.8 ampere times 1 divided by 0.125. Okay, because this is the turns ratio. Okay, then the answer is 6.4 ampere. Okay. Now let us continue to discuss the two types of transformer based on the level of voltage. So first is the step-up transformer. The turns ratio is greater than 1. Okay? Remember, the turns ratio of a step-up transformer is greater than 1. And in the primary side of a step-up transformer, there is a low voltage but high current. And in the secondary side, there is high voltage but low current. Okay? Malinaw tayo dyan, ha? So again, the relationship between voltage and current is inversely proportional when it comes to the transformer law. Okay. While in step-down transformer, the turns ratio is less than 1. Less than 1. The primary side in a step-down transformer has high voltage but low current, and in the secondary side there is low voltage but high current. Okay? So, yan, malinaw na malinaw. Next will be the classification or the types of transformer according to their construction. So first is the closed core transformer, then the Autotransformer, and the shell type transformer. Okay, so these are the illustration of the different type of transformer according to their construction. Okay, the closed core transformer is letter A. Okay, closed core. Okay, then the Autotransformer has a single winding. Okay, for the winding is in a single bar or iron core bar. Okay, and the shell type transformer. Okay, letter C. The closed core transformer is a square core of ferromagnetic built up of laminated layers of iron. It helps to reduce energy losses caused by eddy current. And we will be discussing what eddy current is in the following slides. So having the transformer made of laminated layers of iron, so the result is greater efficiency of the transformer. So kung makikita nyo dito, the transformer ay hindi siya solid. Siya ay made of iron sheets of or iron layers of iron. Okay? Okay, the next one is the autotransformer. It consists of one winding of wire and varies in voltage and current by self-induction. So it is located in the operating console that controls the KBP of our X-ray imaging system. Okay, so that is an illustration of an autotransformer. And the last one is the shell type transformer. It confines more of the magnetic field lines of the primary winding. So the rationale behind this is the secondary is wrapped around it, and there are essentially two closed cores type of or two closed core. So the advantage is the transformer is more efficient than the closed core transformer. So kung makikita nyo nga naman, para siyang dalawang pinagdikit na closed core transformer. Okay? Now we go to the power losses. So there are 4 different categories of power losses. Pero ano nga ba ang power losses? Okay, so sa pagdaloy ng kuryente, okay, nagkakaroon ng mga losses, loss of energy. Maaaring dahil sa kanyang conductor, maaaring dahil sa transformer core, maaaring dahil sa insulator, or maaaring dahil sa ibang metallic portion ng transformer or ng pathway. Okay? So the 4 different categories of power losses are the following. First, copper loss or copper losses, core loss, stray loss, and dielectric loss. Okay. Under the core loss is the eddy current loss and the hysteresis loss. Okay? So yan. So subtype ng core loss ang eddy current loss at hysteresis loss. Okay, first, copper loss. Diba? From the term pa lang, alam na natin kung saan nanggagaling or kung anong klaseng loss to. Copper loss. Bakit copper loss? Because most of the conductor that we are using are copper wire, di ba? So this loss is also called ohmic loss, variable loss, resistive loss, or winding loss. Okay, it is located. Okay, power loss due to the resistance of the conductor. Okay, in this case, the copper wire. Okay, next is the core loss. Okay, syempre core loss. Ano pa ba to? Kung hindi power loss na ang cause ay ang kanyang core or ferromagnetic core. Okay, also known as magnetizing current loss or constant loss. Bakit kaya tinawag na magnetizing current loss or constant loss? Later, we will know why. Okay, pag discuss natin yung dalawang subtype na losses nito. So, sabi lang dito, it is caused by generated alternating flux in the transformer core. Okay, subtype, eddy current loss and hysteresis. So, eddy current loss. Pero una sa lahat, ano ba ang eddy current? So, eddy current is the current that opposes the magnetic field that induces the current. Okay, so therefore creating a loss of transformer efficiency or power loss. Okay, so it is caused by the changing magnetic field in the transformer or the alternating current. Dahil sa alternating current, nagkakaroon ng change in the direction of the magnetic field. Okay, so it can be reduced by using thin sheet of laminated iron instead of using a solid core iron. Okay, as you can see, okay, ang eddy current ay constant. Siya ay hindi tumitigil. Habang may magnetic field, may eddy current. Okay? Or may current na nag-oppose sa magnetic field. Okay. Pag nagpalit ng direction ang magnetic field, therefore, yung eddy current magpapalit din ng direction kasi siya ay opposing current ng magnetic field. Okay, kahit siya ay magpalit ng direction ng magnetic field, magkakaroon ng power loss. Okay, so therefore, the solution that the electrical engineers made is to replace the solid iron core with thin sheets of soft iron and laminating them in order to prevent power losses or reduce power losses. Okay. While the second type of core losses or core loss is the hysteresis loss. So basically, hysteresis loss is caused by the magnetization and demagnetization of the transformer core as a result of the alternating current flow. Okay? So, halos same lang siya ng eddy current loss. Okay, constant din yung loss niya because of the change of the alternating current flow ay nagre-resulta ng magnetization and demagnetization. Okay. The only difference is wala ditong opposing current. Oh, di ba? The opposing current is called the eddy current. Okay. So very clear ha. Sa hysteresis loss, walang opposing current. And then, the stray loss. It is caused by the magnetic leakage flux which produces in the metallic part of the transformer, such as the transformer tank, winding, or cover. Okay, so any metallic part of the transformer can produce magnetic leakage flux, therefore losing power. Okay, stray loss. Kaya nga siya ay stray. Ibig sabihin, nawawala, naligaw. Naligaw yung kanyang loss. Okay, naligaw yung kanyang leakage sa iba't ibang metallic parts ng transformer. So that is stray loss. And the last power loss or losses is the dielectric loss. It is caused by the insulating material or insulation such as transformer oil. So sabi dito, it rarely occurs as compared to the core and copper losses. So madalang na madalang daw siyang mag-occur. Nag-occur lang siya kapag the insulating material or the insulating uh, uh, or the insulation ay nag-degenerate, therefore losing the efficiency of the transformer and producing power losses. Okay, so very easy lang tandaan. Pag dielectric loss, it is caused by the insulating material or the insulation. Okay, stray loss, naligaw yung loss. Dito naman sa dielectric loss, it is caused by the insulator or insulation material. Okay? And that ends our lesson for today. And these are my references that I use in my presentation. Okay? Thank you very much for listening. And don't forget to click on the subscribe button. Again, thank you very much and have a great day ahead of you.